Welcome to Turn Machine Works. My name is Keith, and today we have a new project, or we're starting a new project today. And this project was sent in by Timothy Wagner pretty close to a year ago, maybe a little bit less. And first off, I apologize, Timothy, for taking so long. At first, we didn't know if I was actually going to be able to do this, or if I even wanted to take it on. And I gave it some thought over a period of time here, and I've come up with a most probable, long-lasting, properly confident repair of this slide. Okay, this is a slide off of a carriage on a south bin. I believe it looks exactly like a south bin. Not that he stated that it was, or it looks pretty close to the one I have on my lathe there, and the ones that I've run over the years. I don't know exactly what size. This might be in the 10-12 inch size here. The repair, he has a couple cracked out areas right here, and Timothy says, can you grind out and braze and resurface this slide so that he can put his lathe back together and he's got something to play with and use. Now the two cracks are around these two holes that come in and tighten two wedge pins that hold the round dovetail male from the compound down in here, and that's how it holds down and locks the rotation of your compound. And evidently there was force on trying to push this apart without getting those wedges or loosening up those wedges, and you pop the casting on both of these areas right here. And anyway, those things need to be fixed and repaired so this thing can properly hold that compound down. Now, like welding, brazing is the media that I'm going to use on this, but brazing also causes draw and contraction just like welding does. So no matter how little you do on an item that you're repairing, you're going to have an action or a reaction caused by the action of your welding. So there's going to be some tension on this side because this is the side face that we're going to be working and we're going to be brazing on. So it's going to want to curl it like a potato chip like this, okay? And so this here is your side that actually slides on the lathe. And how much we're going to do, we don't know. How bad it's going to get, we don't know. But we're going to go ahead and we're going to take a couple measurements. We're going to do a couple things to verify what it is now, where it goes afterwards, and how we can deal with it. How much machining we're actually going to need to do. We're going to try to minimize all of our machine work on this thing by creating dams for the puddle brazing. Puddle brazing is where I'm going to actually form the brass right into the wound or the cavity that we're going to be creating when we finish breaking out this area that's already been lifted and busted apart. And I'm going to finish getting all the loose stuff and the bad area completely cleared out. Then we're going to want to put some brazed material into it because I prefer that method on ductile iron or cast iron materials because I like the way it bonds. I like the way the material around the braze is secure. It's not brittle, and I like the hold of it, and I like the way the brass almost lasts exactly the same as the cast material, and also as a bearing area. Not that this is actually going to be like a rotating bearing, but a lot of cases the bronze alloy or brass alloy of brazing does give it that same bearing characteristics that cast does. How I'm going to go about creating the dams, I'm going to use a high temperature conductive graphite material. I've already purchased a couple pieces here. I got it out on McMaster car, and this small diameter, I'm going to go ahead and create two rounds that will be going into the ports here where the set screw and the little dovetail pin goes into. and the large diameter is going to go ahead and create a round that's going to take care of this surface right here. And I'm going to have those at a slight press fit in here, and I'll probably do the big one, then slightly drill through so that this actually passes somewhat into the round one here, and then we'll create a complete dam. After I break these out and I get a little bit more this open, and you know, I can pretty well sense that it's going to be like half the bore on up to the surface right here. That's so that we can minimize ourselves from actually having to go in. We should be able to maintain that roundness of that bore there, maybe a reamer or something going down just so that we make sure it's true. And the round diameter, we don't want to come in here and skim this. We don't want to open this up because then that'll make the compound that much more sloppy. So those are kind of things that we're trying to think about on the compound here, or the slide, excuse me, that the compound mounts to. As we're working on this project, those are all things that you got to put in to consideration for a repair like this. Is, well, how are you going to end up with it? All right. We're going to get back to the start of this, and I'm going to explain to you how I'm going to go about taking measurements and recording what we have here right after this word from our sponsor. Alright, we're back here and we're going to get ready to start taking some measurements on this piece here so that we can verify how much, where it's at now and how much it changes during the process. Now the first thing I'm going to do is go ahead and pull off these screws here that hold the gib plate. And the gib is a inner plate that slides between the dovetail of the carriage and the dovetail of the slide to minimize and adjust over a period of time the amount of wear that accumulates on your lathe. All lathes and all mating surfaces eventually do wear, and the gib is a compensation for that wear. And I'll go ahead and pull all these screws out here, and I'm going to put them in a bag so we don't lose them. And then we'll clear out the holes with a tap and all of that when we're completely done, just in case they have any crispy critter or any debris, dust and stuff like that from our work that we're going to perform on this. They all seem to be easy thread and no damage to any of it. Alright, now we're ready to go. Let's see, there's a bag here. Alright, and we're going to go ahead and seal these up, and we'll put this in a box that he shipped everything in so that it'll be there for us to put it back together. Alright, now I'm going to take some measurements of the thickness along here, both sides. I've drawn that out somewhat out on a cartoon here, and I got thickness and dovetail width. Now dovetail is this surface here on this outside is rubbing, and then this surface just underneath on the both sides here of the underside of the dovetail that's in there. That's what makes contact, and that's what holds the accuracy or your sliding contact surfaces from one to the other on the motion, or the two moving parts, and that's the surface that makes contact. So how do you measure that surface in there? Well, we're going to get two round diameters that we can put in there so that it's making contact, and we can measure in between those, and that'll tell us what that actual span is in there. And what I'm going to do is I'm going to use a set of my thread wires, and I believe these large ones here are going to be suitable. I only need two of them, and that's just because I think the next size down is going to be too small. This does fine because I look in here and I'm making contact with my scale before I make contact with this leading edge right here. Alright, same thing on that side there. So to use the same pins when we finish our project to measure this as well. Now we're just going to take two measurements here, and we're going to take a measurement about half the length of our pin in from this edge, right in between here, and I'm putting the points against this bottom so that I can keep my level this way, and then I'm watching my dial as the closest point here, and it looks like 168, so we'll jot that down, and that's out at this edge here, so that's 1608. Alright, we're going to slide this all the way down to this end here, and halfway in the pin here again. And we got 1610. 1610. So about 2,000 difference between the middle there. Just for curiosity, you want to go all the way out here to the end here. Okay, we got about 11 there. And we got about 13 there. So we got about 11 out here at the end. And we got 13 there. Just kind of a little mental note. Most of your sliding areas, let's just say your full motion is going about that much right there. Okay? But most of your use is like right here in the middle. Right there. Okay? The wear pattern is going to be set for that little area right in there, like the middle of your mill table. Like you have your vise in the middle and you have your spindle coming down, and most of your work is right there, center over your vise. So you never get to the extent of your mill table except for on occasion. So all your wear is in the middle of your table and your slides. Same on a lathe or compound, the same thing as far as how far in it goes, how far out it goes, especially if you sit there and you got 9 inches of travel in and out on your carriage, but you have been doing nothing but machining on things that are 1 inch or so, and your compound only works in that small area all the way to your innermost travel and all the way out to your outermost travel is going to be a little bit tighter because those are unused areas. And so I mean, that's just characteristics of wear on the dovetail. Alright, so we kind of made a mental note of what we have as far as that width in there, giving us the measurement of the underside of that dovetail. Now, let's go shut my door. All right, now that we've gotten back from shutting our door there, and we measured between the dovetail. Now we want to go ahead and we want to just measure the mean thickness, because we have a flat surface that's faced up here, and this is flat here, and these should be parallel. And for the most part, let's see what we got here: 1 inch 30 thousandths. Okay, we're gonna be jotting that down. That'll be here, 1 inch 30. Up here at the top, we got 1 inch 28. Alright, opposite side over here. One inch 27. And down at this opposite end right here, we have 1 inch 30. So I just a slight bit. Let's see, this is like this, okay? So a slight bit of wear on this leading edge over here. Just I'm just trying to picture it's a little bit of a slope here. Pretty even front to back. Just a little bit difference between this side and that side there. That's with these dial calipers, all right? It's just not like I put a micrometer on here. All right, now that we have those jotted down, now we're going to go ahead and we're going to take a look at the overall footprint. Now, let's take a pause. Okay, we moved a few things out of here, out of our way. What we've done here is we've brushed off our steel table. There's no highs on it. We drug the file on it. We just have a piece of paper here. We're not going to work real hard or whatever, but we do want to go ahead and we want to see a little bit of a footprint on here. We will kind of lap this surface after we're all done. And we can see some scrapes and lines from the way it's traveling right here. And we're just going to lightly take and rub it with the paper so that we can see the contact. We're not really taking anything off of here. And I'm looking at a minute amount of scratching on all surfaces, so that is pretty flat and wearing pretty good. A little bit of a hollow right there, but it does look like it's pretty consistent. Alright, now of course we're going to see those high spots from the break, and you can see them right there and right there. Now I'm going to go ahead and I'm going to see if I can finish breaking these out with just a pair of pliers here. I may actually have to grind it. Yeah, I think I'm going to have to grind them. No, but I can definitely see the crack around there in the raised area up. So I'm going to get the rotary burr now, and we're going to work on those areas and prep those out. Alright, I went and got my little pneumatic tool and my burrs, and I put in one of my favorites, and it's just it's a crosshatch burr with a small ball on it. It's about 3/8 diameter, and I think the overall length is about 3/4 or so. But it lets you work on the nose, but out here, and it's really kind of kind. It doesn't create any sharp lines. Another one I kind of really prefer is this 1/2-inch ball, and that kind of lets you get rolling in there. And I'm staying to wide diameters as much as I can, because a wide open area is easier to get braze to seat 100% against the surface. This is a semi cone, but it's radius. It's radius on its outside diameter. It's not like a straight line side here. It does have a curve to it, and then a little ball on the end. And sometimes when you got to work in just a little bit smaller than you can get in with the other diameters here, sometimes I'll put that in there just to make sure that I'm getting it 100% clean. All right, so I'm going to start off with this one right here, and I'm going to go ahead and I'm going to get some gloves on here, and I'm also going to get a face shield just because I'm working this way here, and the air blows out of the end of this thing here, and I'm going to be blowing into that pocket the way I'm holding it, so I know it's going to be ricocheting back up. I have glasses on, and they'll protect my eyes, but anytime that I have a chance on blowing back into my face area, I kind of like to keep ricochets down to a minimum as well, because ricochets can get in and your eyes as well. Other than that, if I was blowing it was off to the side or whatever, and I've used it lots of times where I'm on the outside of something, I don't bother wearing a face shield because I know that the particles aren't going to be coming back to me like a ricochet right into that hole. Not to say that that's right or wrong, it's just my preference. Okay, most of the time also too, if you're going to wear a face shield, keep them clean. If basically the brim is grunged out or the lens is grunged out, there's a lot of different reasons why people don't want to put a visor or a face shield on. Oh, it don't make me look cool or whatever. You know what? It's cooler than an eye patch. All right. Right in this area right here, I can see the crystal of the braking line right in there. The same thing over here. So it's starting to come across into the area that I'm cleaning. And that kind of glossy, and it kind of gives you a mark there. It's almost like reading a dye penetrant line. It almost shows up similar to that. Alright, so I'm going to whittle away on this a little bit. There was just a little chunk that came off. And there it is right there. Yeah, and you can just follow the line of the brake right in your polished smooth surface there. I've rotary burred these a little bit, and I got nice clean surfaces that I can see all nice and shiny around here, and I don't really see any cracks. I do have this line right here that actually kind of looked like it ventured out from where this one was busted here. So what I want to do real quick is go ahead and just clear my table here a little bit and lay my paper back on here. I'm going to kind of get some dust on my paper there too. Okay, now I want to just put this face down and I want to give it a little bit of a rub so I can look at it and I can see if that's a raised area. All of this really is kind of up in the air, and this is, you know, it's touching out here, a little bit there. It is starting to scrape on over in here. Really doesn't definitely show that that is a spot. But we're gonna draw it here a little bit more. Does look pretty flat. It's not much more area, but I think I'm going to go ahead and grind this a little bit right here and get it down to the shiny metal and see if I can actually see if that is anything. I don't want to leave it there. If I start working on it and then it starts a crack, I don't want to leave that there. Any rounded, nice rounded surface that you bond to is going to be a good joint without creating a stress rising area. Alright, and I'm kind of happy. It's about half or less of the round diameter, so I should be able to get enough heat down in here and get the flux and that braze. I should get that right on down in there. When we're doing that, instead of laying it flat like this, we may be working or starting some of this up on its face like this or like this. I might actually even put it in a wall positioner so that I can control kind of the tilt angle and that kind of stuff there to actually make sure that I am getting in there and doing a good preheat to where the material's hot enough all the way around. Most mistakes with brazing is racing right in there and making the brass try to get that brass to stick. If it's hot enough and it's going to take right, the brass will automatically draw to that surface. You don't have to work at it. If you're working at it, it's still not hot enough. Alright, let's go ahead and let's get a little bit more in this area right there. And just, I mean, when I say it disappeared, of course the top surface where it was, you know, that definitely disappeared. But what I'm saying is that it was no more than just being on the surface. I got down in there just below it, just like that. That's probably a 32nd of an inch where that scratch was, and it's no longer visible, meaning all the other cracks I was able to see right in there, and I could see the crack until it was gone. So we're almost completely crack free here. I'm going to do just a little bit of rolling around so that I know that braze will have a nice flowing surface to it. And then we'll go ahead and we'll start turning our graphite to fit up into these bores here. Alright, we got our lathe cleaned up. We have the big piece, 1.5 inch, I believe is the diameter we have. And this bore here measures out to be 1 3/8. And the small bores, we know that is 5/16. And what we got to do is we got to turn probably about that long of a diameter on this one here to be 5/16, just because they didn't have any standard or stock size. Actually, this is over a couple thousandths, and the other piece I have is a little bit oversized. They make it oversized so that you can finish it off. You can turn graphite or high heat graphite with carbide bits, and we're also going to be running our vacuum cleaner because this is very, very powdery material, and it just makes a big mess and it turns everything blacky. I mean, it's just like your pencil lead. That kind of a blackness, or if you're doing a lot of charcoal sketches, same kind of thing. You get the black all over you. So we got those two sizes right there, so we're going to start playing. We're going to go ahead and we're going to get our micrometers for our 1.5 inch size and our 1 inch micrometer, and the two hole gauges. Hole gauge for the 5/16, which I pretty well, if I get this fit right here, I'm going to be pretty happy with that. And then our snap gauges to let us get in and make sure that we're right on the money within a thou or so there. I would like a slight bit of a press fit, and then these things here I'm going to go ahead and drill in and probably ream into the center plug so that this pin will pass through that face surface and into the big piece right here. And then that dam that we created will be 100% for the braze that we're going to add here and here. We're going to go ahead and we're going to take a face cut on this, and then we're going to take a diameter cut. We snap gauge the bore, and it's actually 1/1000 over 1 3/8, so it has about 1/1000 clearance. I figured in there, and we'll put it in there. This is 1/454. So here we go. We're going to go ahead and take another cut. .5, we're getting we're getting close here. Okay, we got about 28 to go. Funny, I mean, the hose is sticking there, so I guess I found a sweet spot for it. Nothing is interrupting it. Alright, we got 8 thousandths to go. Okay, that should be a snug fit to it. Let's check it out. I don't know if coming in from underneath or what. Okay, a little bit of roughness around these boards right here. That is pretty snug to it. I'm going to give it a little polish with paper for a couple seconds here, see if I can get it. I know it goes real fast, so you don't want to do that. As you just see by my micrometer here. Alright, that already took 1,000s off, so. Alright, it's coming all the way through. Alright, even on this bore, looks nice and shiny around there where it's rubbed, it's tight. Now I'm going to go ahead and part off a section right here. Alright, now we're going to turn our two 5/16 diameters. Now we'll be putting this in there and drilling into this through our ports to get those two other matching points there, and we'll be ready to start brazing.